This is Geometry, Unit 4. We're going to be classifying polygons today. When we talk about a polygon, it is a closed plane figure. That means all the vertices are going to come together. It is formed by 3 or more segments, and the segments are called sides. So a polygon, one that you're very familiar with, all the sides are coming together. It's called a closed figure. It's not open. So this would be a triangle, we would know it as. That would be a polygon. What would not be a polygon would be something that wasn't closed. It was opened or that crosses. That would not be a polygon. Each side intersects exactly 2 sides. So if you have a side, it's going to intersect a side over here, and it could intersect a side over here. You can see that is true for a triangle as well. Each one of these sides is intersecting 2 other sides. So this side here is intersecting this top portion and another one. This side is intersecting 2. This side is intersecting 2. At every vertex, the vertex is the point in the corner. At the corner, it has 2 segments coming off of every vertex. That is true for any polygon, including triangles, quadrilaterals, and all the sizes that are bigger. What we're not going to use as polygons, we're not going to use what's called a concave polygon. This is a concave polygon. We won't be working with concave polygons at all. All of our polygons will be convex. Convex polygon, any 2 points that are on the figure, if you would connect those, you would be on the interior of the shape. If you look at over here, if you connected these 2 points together, you would be on the exterior of the shape. So that's an easy way to identify if you are concave or convex. Concave has a cave in it. Convex does not. The vertices always point out from the shape. Concave, the vertice is going to point into the shape. We're not going to work with concave. We're only going to work with convex. Down here, we have a variety of different names that go with these number of sides. So to have 2 sides, you don't have a polygon using 2 sides. You can't make a closed figure with only 2 sides. But of course, you can do that with a triangle. You can draw 3 sides. That would be a triangle. Quadrilateral is going to have 4 sides. Now, there's a whole bunch of different types of quadrilaterals. But a quadrilateral is any polygon with 4 sides. Pentagon is going to have 5 sides. And you can keep going if you want to try to get creative in here. You could draw one with 6 sides, typically flat on top. Got the edges, then it points to the sides, and it comes back together. It's kind of small, but that would be a hexagon, 6 sides. Heptagon's going to look pretty close to what a pentagon looks like. An octagon with 8 sides is going to look a lot like a hexagon. A nonagon has 9 sides. A decagon has 10 sides. Everything besides that, we can just call an n-gon. N-gon for a number of sides. So sometimes you might hear it say a 14-gon. That's implying that it has 14 sides. Or a 22-gon, that it has 22 sides. An n-gon refers to any size polygon. So when we're working with polygons, any type of polygon that has all equal sides. Here's an example of one. Equal sides. They all have the same tick marks. So all sides are congruent. That is true for every equilateral. We typically call a triangle equilateral if it has all sides the same. But this quadrilateral would also be considered equilateral because it has all sides the same. Equiangular is going to have all equal angles. You can see the word angles pretty close to in here. Angular. So all angles are congruent. So if you hear something is equiangular, it has equal angles. If you hear something is equilateral, it has equal sides. Lateral meaning sides. Now, if you're both, if you're equilateral and equiangular, if you look here at this shape right here, this guy does not have all equal angles. Here's an acute angle, and on the other corner we have an obtuse angle, bigger than 90. So these angles clearly are not the same size. So this is not equiangular. This is just equilateral. But if you did have all equal sides and equal angles, you would be considered a regular polygon. A regular polygon, got to remove these two words, has both congruent sides and congruent angles. That would be a regular polygon. So a very famous regular polygon would be a square. A square has all equal sides and all equal angles. Here we have one. We're going to classify the polygon by the number of sides. So we have to count the number of sides. We have 1, 2, 3, 4 sides, 5, 6, 7, 8 sides. We notice that all the sides are the same length because they have the same number of tick marks. And we notice that all the angles are the same because they have the same number of angle tick marks. So this would be considered a regular octagon because it has 8 sides. Octagon. Now we compare that over here with this quadrilateral. This has 4 sides. You can notice that 2 angles are the same. They have the same number of tick marks, but these tick marks are different. These have 2 curves apiece. So these have a different measurement than those are. So all the angles are not the same for this quadrilateral. So this is not a regular. It also only identifies 2 sides being the same. It does not identify all 4 sides being the same. So at the moment, the best name we know for this is just quadrilateral. In the future, we might be able to call this a trapezoid. And if it has 2 sides the same like this, maybe it's an isosceles trapezoid. We're not going into that depth at the moment, so the best name that we can call it is a quadrilateral. Now, triangles are pretty common. We have some special names. You're probably pretty familiar with this. For years, you've heard about a scalene triangle. No congruent sides for scalene triangles. Isosceles triangles have at least two sides the same. We typically just are looking for two sides being the same. We call it isosceles. But it would be all three sides the same would be isosceles also, because the definition is at least two sides. But if it has three sides, we would be more specific about equilateral triangle. If all three sides are the same measurement, 2 tick marks, 2 tick marks, and 2 tick marks, it's going to be considered an equilateral triangle. All three sides congruent. An equilateral triangle is also an isosceles triangle. It also has at least two sides the same. So that's where this definition of at least comes from. So that should be pretty straightforward for you. On the flip side, we classify our triangles by angles. We've done this already this year. We've talked about acute triangles. If all three angles are less than 90, if they're all acute, they would be acute triangle. If you have a right angle, you can't have two right angles in a triangle. You can't have two 90-degree angles in a triangle. But if you have one, then you're considered a right triangle. If you have one obtuse angle, because you definitely can't have two obtuse angles, if you have one obtuse angle in a triangle, then you're considered an obtuse triangle. But you have to have all three acute angles to be considered an acute triangle. This would be one right with two acute. This would be one obtuse with two acute. Here we have all three acute. Well, this situation, we have all three acute also. But they're all the exact same measure. Anybody know what the measure would have to be for a triangle if they were all exactly the same? Would it matter? Maybe we could change it. Could we make a triangle that had 50 degrees, 50 degrees, and 50 degrees? It's actually every triangle, every one up here, and every one you can possibly draw, as long as it's truly a triangle, they will always add up to 180 degrees. It's a fun fact. We'll talk about that more in the future. So an equilateral triangle, if they're all the same, that's 180 divided by 3. Each one of these would have to be 60 degrees. If it's 60 degrees, then it would be an equilateral triangle, which would also have all equal sides. Kind of a fun fact. If all your angles are the same, all your angles will be the same. So there's a lot of definitions, a lot of vocab words, many that you're familiar with. Okay, an equilateral triangle is also equilateral. Equiangular is also equilateral. If you have all equal angles, you have all equal sides, and the other way around also. If you have all equal sides, then you have all equal angles. You would be considered a regular triangle. An equilateral triangle is going to have all equal sides. Equiangular triangle is going to have all equal angles. And those equal angles would have to measure 60 apiece, and that would fall underneath the category of acute. All right, last one. We're going to classify our triangle RST. Which type of triangle do we have here? You want to give it a prediction on what you think that might be? Can we classify it by its angles? What type of triangle do you think this would be just by looking at the angles? Obtuse would imply that one of those angles is bigger than 90 degrees. And if we take a look at each of these corners, oh, that one is pretty darn close to 90 degrees. I was not expecting that. That's really close. It may not be exactly 90, but it is darn close to it. There's a way we can test it. We can find out. This one out here clearly is not. If you take a look, if that would be a 90-degree corner, this side coming in this direction is way less than 90 degrees. So this could possibly be considered a right triangle. We'll have to see what we know about the side lengths. Maybe we have two sides the same. Maybe we don't. Huh? So we're going to use what's called the distance formula. x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And we're going to calculate the side lengths for each of these for each of the sides of this triangle. Point R. Point R is negative 3, 3. I'm going to write it over here so it's a little closer to our work. And side S, or point S really, it's not side S, it's point S, is 5, 2. So we'll call this x1 and y1, x2 and y2. Look how I labeled those. For a single point, like the R point, it has an X and a Y for it. Some common mistakes are that when people do the distance formula, they put both the X value and the Y value in the parentheses. But that's not the way it should work. You should put your X2 value, which is 5, then minus your X1 value, which is negative 3. So we need to minus a negative 3. So this is going to be RS equals X2, which is 5, minus X1, which is negative 3. And we square it. Plus Y2, that looks like that is the number 2, minus y1, which is 3. Then I draw my line over my square root. So 5 minus a negative is really 5 plus 3. And 2 minus 3 gives you negative 1. So this is going to be 5 plus 3 squared, which is 8 squared, 64. And what do we get when we take negative 1 and square it? Negative 1 times negative 1 is a positive 1. So this side length is considered square root of 65. We won't worry about a calculator. We don't need a decimal for it. That's as simplified as it gets. 65 is not made up of a 4 or a 9 or a 25 or even a 16. So that's the best that we can do. We'll look at the side length of RT. We know that R was negative 3, 3. T is 3 comma negative 1. Label your points x1, y1, and x2, y2. And you try to calculate your own distance for RT. Pause the video, give this a try, come on back, we'll talk you through it. So for RT, my x2 number was 3, so parenthesis 3, minus, so put it down a minus symbol. X1 was negative 3, so I put that in parentheses, plus, parenthesis, y2, negative 1 minus, y1 is 3. So that's going to be 3 plus 3 squared. And negative 1 minus 3 gives us negative 4 squared. 3 and 3 is 6. 6 squared is 36. Negative 4 times negative 4 is a positive 16. This comes out to be the square root of 52. So we can see that that's different already. The square root lengths are different, so those sides are not the same. We can do it again for ST. If S is 5, 2, and T is 3, negative 1, we take our 3 minus 5 squared plus negative 1 minus 2 squared. That would give us negative 2 squared plus negative 3 squared. And that comes out to be 4 plus 9, which is the square root of 13. So this gives us a scalene triangle. Looking at our slopes, our slope for RS can just be counted from R to S, down 1 over 1, 2, 3, 4, 5, 6, 7, 8. Has a negative slope, so it's 1/8. RT goes up 1, 2, 3, 4 over 6. Up 4, but to the left 6, so that can be reduced to negative 2/3. And then my final one, ST, would be up 1, 2, 3 over 1, 2. And there you see opposite reciprocals. Which are perpendicular. So we did have a 90-degree angle in that. So this would be a scalene right triangle. Scalene right triangle because we had opposite reciprocals. Flip the fraction and change the sign. We talked about that when we did our equations. This one here can be simplified. The best would be 2 root 13.